So this is pretty ideal, really, and it's really quite easy to do. But the problem is the browser support is really quite good, but not good enough yet. It's Firefox 3 and up, Safari 4, Chrome. I don't know what version it started. It might have been as soon as it came out. Opera 9 and up. Opera 9 does things a bit strangely, but Opera 10 support is pretty good. And yeah, even IE8 supports post message. But there's a few notable exceptions. If you want to do something that's got to be usable by the majority of people across the web, you've still got to make a solution for IE6 and 7 at least, which is then when you have to resort to the poor man's post message. So the second best option after post message is actually to use a facility of Flash called local connection. The basic thing is you have a Flash movie in the client iframe, the client window, and then you have another Flash movie in the server iframe. And local connection just allows any Flash movie that's instantiated in any window on the browser, and even ones on desktop, to just sort of directly talk to each other. The security model is kind of usefully similar to how post message works. So you can either lock it down to a certain domain, or you can say just send a message to wherever. So it works quite well. I would go into the ins and outs of doing this, but frankly, this is how I become when I talk about ActionScript. And you don't want to see me when I'm angry. The next, and by far the most ghetto way of doing this, if you really must, is by exploiting some strange properties of window.name that actually sort of works in IE6 and 7. And the way you do that is basically one window can set the window name of any other window, but it actually can't read it. So what you do is, in this case, the server iframe sets the main window's name and puts some JSON in it. And then to get that data, the main window just can simply like poll for changes in that window name, and then take that name and do things with it. And obviously, this is like works, but it's fraught with problems. There's a very, very limited message size because there's some kind of limits on how big window names can be. I was trying to look those up last night, but I was a bit drunk and the screen was frozen. It was confusing. But you could look that up somewhere. It's not much. There are also problems when you're trying to post messages in quick succession. Because you're relying on a poll, if you send two messages very quickly, one overwrites the one before it, before the poller has managed to grab the data, so you sort of drop messages sometimes. There are ways of slightly mitigating that problem, because you can, rather than polling, you can do tricks with triggering a window resize, and which then tells the JavaScript to go and grab a new value. But you basically always tend to lose some values unless you implement some kind of queuing system where you send a request and then you wait for the reply before you send the next request. So, but even so, then it's everything's in serial, so it's much slower. So once we sort of mix together all of these things and come up with a cross-browser solution for sending information from one frame to another, the next stage is actually implementing a remote procedure call layer that allows the client side to be able to make calls that go to the server iframe, and then for the server iframe to then send results back asynchronously to those methods. So in the server iframe, we actually generate this stuff programmatically at Twitter, because we have like a manifest of all of the API endpoints. So I read that in, and then actually produce code for these, for the public methods. And this is an example of what one looks like for account verified credentials. It's kind of simplified here, doesn't handle errors in this case. But essentially what we do is we have this hash of public methods that we want to expose, and then we basically call AJAX from inside server HTML that can get to the API, collect the result, and then send the response back. And you'll notice that we're sending a UUID as well as the data, and I'll show you how that works. So we've got these public endpoints. What we need to do now is send a method call to those public methods we've exposed. And this is a very simplified version of the code that you would use to do that. So to make a remote call, you pass in like a method, some arguments, and a callback to actually call when you've got the results. We generate an individual ID for each one of these callbacks and then store the callback in a hash that's keyed by that UUID before we make the call. The reason we do this is when we're returning a response on the other side, we'll call the public method, passing in the things that we've the method and arguments and everything, and the UUID, and then back in here we actually pass through the UUID back, which means when you're receiving the result on the other side, we can get the corresponding callback for that UUID and call it when it returns. And that enables us to basically send many requests for information and not necessarily have to receive them all back in the same order. So after we have this working and we're able to make calls and receive responses over that domain, we need to get onto authentication and authorization. And the typical scenario is this. So in the previous examples, we have a site that we like Twaudio is a trusted client, and that's fine. And it embeds our server iframe, and it talks to it and gets information about users and follows people and so on. But then, what happens if evil.com just takes that same server HTML and embeds it in an iframe in its site and starts trying to post method calls to it? Well, we don't want to give information to any old site. We need to verify this call. And there's sort of three things we need to know to make this work. We need to be sure that the client is who they claim to be. We need to know who the user is that they're going to act on behalf of. And then we also finally need to know that the user has authorized the client website to take actions on their behalf. So I was considering this at the start of the project and wondering how to solve this. I was actually sort of standing on the toilet and I was trying to put a clock up. I fell over and I hit my head. And it came to me in a flash. The answer is a flux capacitor. Well, actually, no. It's not quite that easy. The problem with browser-only authentication is normally authentication schemes rely heavily on secrets, things that people don't have access to generally, and that's how OAuth 1 will work. But the thing is with browsers, is they're rather like this guy, because they really can't keep a secret. So that's a totally crappy joke. But as it turns out, the people that came up with the great solution to this problem were Facebook, and in particular this guy Luke Shepherd. And if you ever want to, if you ever think of implementing something like this, you should go to his site, because there's loads of really in-depth articles on all of this stuff. What he came up with in particular was what is now called the user agent flow of OAuth 2, and it's still in draft, and little details about it literally change every couple of days. So this could be out of date from last night, because there's lots of parties that all like to squabble about parameter names and stuff. But the essential idea is we encapsulate these sort of three things that we need to know about as an access token. So if the service is happy that the client is who they say they are, and they know who the user is, and they know that that user has authenticated, has authorized that client, then we give them an access token, and with that access token, they can send requests and get